Hello everyone, welcome to my channel. Today in this video, I'm gonna talk about logic gates. So there are 7 types of logic gates. I'm gonna cover those logic gates today. The first one is the AND gate. Second is the OR gate. Third is the NOT gate. Fourth is NAND gate. Remember one thing, NAND gate is the opposite of AND gate. And fifth is the NOR gate. NOR gate is the opposite of OR gate. And the sixth is the XOR gate, which is exclusive OR. And the last one is XNOR gate. So AND OR is called exclusive NOR. Exclusive NOR. So those are the 7 types of logic gates. These are the 7 logic gates. So now I'm gonna briefly talk about this 7 logic gates. So the first one is AND gate, right? Now I'm gonna show how the AND gate looks like. So this is how the AND gate looks like. This AND gate has 2 inputs, which is A and B, and 1 output, which is Y. So these 2 are inputs, and this is the output. That's it for AND gate. Let's go to the OR gate. This is how the OR gate looks like. There are also 2 inputs, A and B, and 1 output, which is Y. Then NOT gate. NOT gate is slightly different. It looks like this. There is like a bubble, which is called the inverter. NOR gate only has 1 input and 1 output, which is A. A is the input and Y is the output. So this bubble is called the inverter. Whenever there is a bubble, so this is how the NOT gate looks like, but later I'm gonna talk about when there is an inverter, there's gonna be a change in the equation. Let's go to the next, which is the NAND gate. As I have shown, the AND gate looks like this. This is the AND gate, right? And now I'm gonna draw the NAND gate. There's only slightly one small change. There's gonna be an inverter. The bubble. This is the difference between AND gate and NOR gate. This is the difference between how they look like. Then the NOR gate. NOR gate is also slightly different from OR gate. OR gate looks like this. And this is how the NOR gate looks like. It's gonna be exactly same like the OR gate, only the difference is there is a bubble, which is the inverter, Y, A, and B. XOR. or exclusive OR. Exclusive OR is, first of all, you have to draw it like a OR gate. Then you have to just put a line over here, like a curve. And there's one output which is Y, input is A and B. Exclusive NOR. XNOR. There's gonna be an inverter, and this is the same as the exclusive, or the inverter is the only difference. So right now, as you guys know how all the gates looks like, as you guys know all the drawings, I'm gonna show you guys for the AND gate, the output is on only when all inputs are on. So for the equation for AND gate is A times B is equals to Y. For OR gate is A plus B is equal to Y. You add the two inputs and get the output. For the NOT gate, as I said, there's like only one input and one output. So it's gonna be A equals to Y. There's an inverter on the NOT gate. What you have to do is in the equation you have to put a line, a bar over A, because whenever there's an inverter, which is a bubble, you have to make sure that there's a bar over. So next is the NAND gate. So as I said, when there is a bubble, this inverter, you have to make sure there's a bar. There's bar over the equation. So this is A, this is B, and this is Y. The equation for NAND gate is AB bar equals to Y. For the NOR gate, there is an inverter. Don't forget that when there's a bubble, you have to make sure that A plus B is same like OR gate, OR gate's equation is A plus B equals to Y. And in this is A plus B equals to Y. Only because of the bubble, you'll have to make sure there's a bar. For exclusive OR, as is slightly different, it's gonna be A plus B equals to Y, but you have to make sure that there is a circle on the plus. For XNOR, as there is a bubble inverter, you have to make sure the equation is A plus B equals to Y, circle on the plus, and a bar because of the bubble. So far I have shown you guys. So right now I'm gonna show you guys a truth table, which is the most important part of this gate. So the truth table for AND gate. So AND gate, first of all, you guys have to know how to make a table. First, you have to write A, B, which are the inputs, and the output, which is Y. Let me write the AND gate equation, which is A times B equals to Y. For truth tables, you have to make sure the input is 0, 0. Both the inputs are 0 for the first row. For the second row, it's going to be 0 and 1. Then for the third row, it's going to be 1, 0, and 1, 1. I'm going to write 2, and as there's two inputs, I'm going to write 2 to the power 2, which is 4. That makes me understand 2n. That makes me understand that I have to make 4 rows. So after making 4 rows, as I said, AND gate, the output is on only when all inputs are on. So as I can see on A and B, these two inputs are 0. 0 means off and 1 is on. So as these two are 0, inputs are 0, it's gonna be 0 because AND gate is the input is on, output is on only when all inputs are on. So these two inputs, there's one off and there is another one is on. So it's gonna be 0. So for the last one, both inputs are on. So the output is gonna be on. So for rest of them, it's gonna be 0. Let's do for OR gate. OR gate, the table is gonna be the same, 4 tables. The equation is slightly different, which is A plus B. And for OR gate, the output is on when at least one input is on. So it's saying that at least if there is one input is on, the output is gonna be on. So in this table, which we can see that the second row has one input on, so it's gonna be 1. Third row, one input is on, so it's gonna be 1. 2 inputs are on, so it's gonna be on. Only the first row, both the inputs are off, so it's gonna be off. OR gate is saying output is on when at least one input is on. Make sense? Let's go to NOT gate. NOT gate has one input and one output, which is A equals to Y. So the table is also gonna be small like this. So it's gonna be an AND gate is also called an inverter gate. Inverter gate. So it's gonna be 0, 1, 1, 0. This is the truth table. For NAND gate, let's write the inputs A, B, and the output is Y. So it's gonna be 4 tables, as I said. 4, 2, 3, 4. So for truth tables is 0, 0, 0, 1, 1, 0, 1, 1. NAND gate is the opposite of AND gate. So when we were looking at AND gate, you could go back and see the video when I was showing the AND gate. The AND gate was when all the inputs are on, the output is on. For NAND gate, if the output is off when all inputs are on. So as I can see that NAND gate is the opposite of AND gate. So when we were doing AND gate, let me draw the truth table of AND gate here. Let me write it here. So for AND gate, the results were 0, 0, 0, 0. When all the inputs were on, was on. But it's the opposite for NAND gate. For NAND gate, let me write it down. It's gonna be opposite. So as those were 0, is gonna be 1, 1, 0, 0 for this. For NOR gate. NOR gate is the opposite of OR gate. So this is the OR gate. NOR gate is the opposite, so it's the NOR gate. NOR gate, as this is 0, it's gonna be 1 for NOR gate. This one is 1, is 0, opposite. 1, 0, 1, 0. This is how it works. It's very easy to remember. NOR gate is the opposite of OR gate. NAND gate is the opposite of AND gate. That makes it easy. NOT gate has an inverter and it has only one input and one output. Now is the end. I'm gonna write the XOR, exclusive OR, truth table, and exclusive NOR truth table. Exclusive OR. For exclusive OR, the output, when the output is on, the output is on when odd number of inputs are on. And for the XNOR, the output is on when you have even number. Even number of 1 and 0. So this is the difference between XNOR and XOR. So let me draw the truth table. XNOR, XNOR. For the truth table, A, B, Y, 0, 0, 0, 1, 1, 0, 1, 1. The definition was saying the output is on when an odd number of inputs are on. So odd numbers of inputs, 0, 0 is even, so it's 0. 0, 1, there is odd number, so it's 1. 1, 0 is odd number, so it's 1. 1, 1 is even number, so it's 0. For exclusive OR. 0, 0, 0, 1, 1, 0, 1, 1. In this, it has to be even numbers. So 0, 0, even numbers, so the output is going to be 1 on. Well, 0, 1 is odd numbers, output is going to be 0. Odd numbers, 0, even numbers, 1. Hope you guys liked my video. If you have any questions, feel free to comment and feel free to like my video and subscribe. Thank you for watching.